A very good morning to my dear students. Hope you all are well. I, Hareeta Malani, working as an assistant professor in Electronics and Communication Department of MLB Textile Engineering College, Bhilwara. Today we are discussing one more topic of operational amplifier and how it can be used to design adder, subtractor and voltage follower circuits, which are very basic circuits, and everywhere these circuits are required to design some big circuits. So we will start with the aim of the experiment to study operation amplifier as summer, subtractor and voltage follower. So here the apparatus required will be, as we all know, we will perform this experiment by using operational amplifier IC 741. So IC, digital multimeter, resistors, connecting wires, DSO, digital storage oscilloscope to measure the output, or directly we can use multimeter also. Function generator or signal source, power supply, breadboard and connecting wires. Here we can apply input. As we all know, operation amplifier is a versatile device. We can connect AC as well as DC inputs. So here we can have AC as well as DC inputs. If we are connecting AC inputs, we have to use function generator, and to measure output we need DSO. If we are directly connecting the DC sources, then we can directly measure the output on multimeters. So first we will start with voltage summer. Summer is a circuit which is used to sum n number of inputs, and it gives the output as addition of all those inputs. Here we are having n number of inputs. All different voltage input voltages are connected. The output voltage will be the addition of all this input voltage. The summing amplifier is an application of inverting operational amplifier. The summing amplifier has two or more inputs, and its output is proportional to the algebraic sum of its input voltage. So this is the basic circuit. Here we are using inverting mode voltage summer, as all the input voltages V1, V2, V3 are connected to the inverting terminal. One feedback resistance RF is also connected, 3 input resistance, and the basic condition to generate a summing amplifier is that this resistance, input resistance and feedback resistance should be same. The ratio should be 1, so that directly, that means there should be no gain. It should not be an output, should not be an amplified version of input. Directly we should get the addition of all the input voltages. So this is the basic summer diagram, the circuit diagram we must say. Now we are applying 3 different input voltages. We can have 5, we can have 6 input voltages, any number of input voltages we can connect. Here we are connecting DC input voltage. So what I will get, these are the equations to simplify and to get this equation of summing amplifier. So IF is the feedback current is equals to I1 plus I2 plus I3. We all know current is the ratio of voltage upon resistance. So these resistances are connected. Inverting equation, we all know that V output is equal to minus RF upon Rn into V in. Gain is equals to minus RF upon Rn. This ratio we all know. Then we are substituting this thing in this equation. So I got RF into V1. V1 upon Rn, then minus V out is equal to ratio of all the input voltages V1, V2, V3. So minus V out, RF upon Rn taken out to be common, as all the input resistance values are same. Now I got the equation minus V out is equal to RF upon Rn, addition of all the voltages. Now what I have to assume to get operational amplifier as a summer, the basic condition is that feedback resistance and input resistance should be same. So I will get V out is equal to minus of V1 plus V2 plus V3. So this is the basic of operational amplifier as an adder. So I got this equation, and this is the circuit diagram. All the resistance values should be same. So next, voltage subtractor or differential amplifier. We all know subtractor is a differential amplifier because here we have to connect both the input voltages at inverting and non-inverting terminal. That means both the sources will be connected to inverting and non-inverting terminal. Here we cannot connect all the sources at only one of the terminal. So differential amplifier means it amplifies the difference of two input voltages at the output. So here we are having differential amplifier with two inputs V1 and V2. We can have any number of inputs, like I can have equation V1 minus V2 minus V3. V3 will be connected over here. We can have 4 number of sources, 5 number of sources, any number of sources you can have. So here for the basic designing we are using 2 input voltages to be subtracted. Is it clear? Next, all the equations are given. Current I1, I2, IF. Summing points VA is equal to VB. VB is the feedback voltage. This is my virtual ground condition. VT is equal to 0. Then I will find out with respect to another voltage V out A, V out B. So V out equation comes out to be this. V1 R3 upon R1 plus V2 into this resistance ratio. When resistance R1 is equal to R2 and R3 is equal to R4, the above transfer function of the differential amplifier can be simplified in the following. See, we have to find a simplified version of this equations, and at the output we all know we just want V2 minus V1 should be the output. So we have to manage and assume some parameters to simplify this equation. So we will assume that R1 is equal to R2 and R3 is equal to R4. Now I got this ratio after assuming this. So V out is equal to R3 upon R1 in bracket V2 minus V1. V2 minus V1. Now again one more condition is left, that R3 should be equals to R1 to get V2 minus V1. So here I assumed if R3 is equal to R1, then V out is equal to V2 minus V1. So I got output voltage as the difference of two input voltages. Next circuit is a very basic circuit, but it is used in many applications. That is known as voltage follower, and it is a basic application of non-inverting amplifier. This is known as a buffer amplifier, where we can preserve or we can store data for a few seconds. So buffer is a device. The advantage of the circuit is that op-amp can provide current and power gain. The op-amp draws almost no current from the input. See the circuit diagram, what is happening? No resistance is connected, just a power supply source is given to non-inverting terminal and no feedback resistance is connected. So it provides low output impedance to any circuit using the output of the follower, meaning that the output will not drop under load. The load is a 1 kilo ohm resistance we can use at the load side, and no RF, so therefore no amplification. Output voltage is equal to input voltage. So this is a voltage follower circuit. Now procedure, simple procedure, mount all the circuit on the breadboard, and if we are performing this on simulation software, then all the components you have to use from simulation panel over there. So connect all the circuit, connect inputs and outputs, and start measuring the voltages. Now this is the observation table. For summing amplifier, we are having 3 input voltages. Theoretical value, if I am having 1 volt, 2 volt and 3 volt. So total theoretical value will be 3 plus 2 plus 1 is 6 volt, but practically I can get 5.9 volts, 5.8 volts, so I can calculate the error, and if I am getting exactly 6 volt, then percentage error will be 0. Similarly for subtractor, we are having 2 input voltages, V1 and V2. Theoretical value, if I am assuming V1 is 3, V2 is 2, I will get V2 minus V1 minus 1 volt. The theoretical value we will calculate, same practical value we will measure, and we will find out the percentage error. Similarly for voltage follower, just what we have to do, we have to give the input, we have to measure the output. Input output should be same. There will be no change in voltage follower circuit. These are the diagrams for simulation software. How it is designed by using simulation software. Inputs are applied and we are getting the output. Here one sine wave input and one square wave input is given. Now I am getting the output as addition of this square and sine wave. So you can see the distorted output. Here constant axis, then again there is a transition, then again positive half. So both the signals get added. Similarly for voltage follower, we are having no feedback resistance, just input is applied. So this is my input and this is my output. So there is no change in the circuit and we are getting exactly output. So here we have studied application of op-amp as adder, subtractor and voltage follower, and it's very easy to perform. Measure output voltage, verify theoretical and practical values. So this completes your experiment. Thank you, students.